In this video, I'm gonna be explaining step down voltage regulators. I apologize for not having done this and just explaining voltage. So now, firstly we will need our linear regulator LM317. This is a very famous IC chip actually. Now, just like in the step up voltage regulator, how we used the IC over there. So right, just like that, LM317, it's a three-way positive voltage regulator. It's an IC, basically integrated circuit. It can be used as a key component in mainly step down voltage regulator circuits. So what it does, it provides a regulated output voltage that is basically lower than the input voltage. So basically from here, this is the first pin, that's the input pin. So if the voltage was approximately give or take 10 volts, and according then the output voltage would be lower than that. It's a regulated voltage would be lower than that. So just step up voltage regulators, they just boost the voltage a bit. That is exactly opposite to that. It just reduces the voltage, reduces the output voltage. Now that is obviously done with a feedback mechanism. Also explained in the last video what feedback was. So right, so that's it pretty much about LM. Is there nothing else? Basically, this IC also, I think, this IC also uses a feedback mechanism. Then basically to reduce the regulate the output voltage. Then the first pin is input. This pin is the output, and this is the adjust pin basically. Adjust pin basically it's like it's used to differentiate between the reference voltage and the output voltage. So that's input, that's output, and the voltage in the output pin is compared to an internal voltage reference basically. So that's it. So basically this is a versatile and a reliable IC that can be used in pretty much like various applications, including step down voltage regulator circuits. That's the gist of it. So I'm so sorry, 1 second. Okay, so first we would need a voltage source. So we'll take the DC voltage. Then we would need, let's keep this 10 volts please. Let's take input voltage as 10. We'll take it as 8. Okay, we'll start with 10. Then we'll take, what else do we need? Yeah, we need capacitors. We need capacitors. Capacitors. So 2 capacitors, 1. All right. We would need resistors. So couple of 2 resistors. So is that. Alright, then we need obviously the ground connection. We need ground. We also need a probe actually. We'll take the probe later. We'll take the voltage probe. And I have everything, right? I do have everything, I believe. Okay. So now we will. So firstly, the capacitors. Adjustment to ground. Yeah, that would be better. And the voltage source obviously to the input, output to second resistor through the 240 back to, and then we need the capacitor. We need the capacitor obviously between these two. We need the, yes, so okay, so now the ground is not attached properly. Now it is. Yes. Now almost done. We have the resistor here. Okay, the last capacitor lock comes in handy now. Yes. All right. So this is the step down voltage regulator basically. The left pin, the input pin, that will be the flash over here, that's connected to the voltage along with the capacitor. The rightmost pin, which is basically the output pin, that's the output voltage. Then we have the capacitors. We have two capacitors and then two resistors. Ground and the first resistor attached to the edges pin. Now almost done. Now in this circuit we are using the LM317, which is basically the linear voltage regulator. From here, if you see this is the linear regulator. So we use this IC to reduce the output voltage from a higher voltage to a low voltage. And basically the resistor and the IC, they form a feedback loop. So that is what reduces the output voltage. And the capacitor is charged to a voltage higher than the input voltage itself. So when the capacitor's voltage is regulated by the IC to produce a stable voltage, now that's the time the resistor sets the output voltage by changing the reference voltage, which is the first voltage, which is then compared to the capacitor's one. So that is basically the step down voltage regulator. One more time, first of all, the IC we use is LM317. That's the voltage regulator. We use this IC to reduce the input voltage from a higher voltage to a low voltage. Then the resistor and the IC, they form a feedback loop. So that reduces the output voltage by changing the reference voltage for the IC. And when this current flowing in the circuit, that is when the circuit is powered on, the capacitor gets charged to a voltage higher than the input voltage itself, which is here, I think, yeah, it's 10. So then the resistor sets the output voltage by changing the IC's internal reference voltage, which is then compared to the voltage across the capacitor. Done. So this is the most simplest and efficient way to set up a voltage step down voltage regulator using LM317. So it can be modified, obviously it can be changed. All you have to do is change resistor and capacitor values to get different output voltages. That's it. So about IC explanation is done. So now we need the observations, especially the graph. Yes, so firstly we'll have to go to schematic. Yes, good. And we can press run. Split. Okay, my bad, one second. Yes, sir. So now I have changed the simulation options, and okay, this is step. Sorry. So now if we simulate, we do have, yeah. So that's it. That's the basics of step down voltage regulator. And from the readings we can, from the graph, we can take our input and output voltage. So the straight line meant it's constant right now, but so that's it. So that's the IC capacitors, why resistors are there, why voltage source is 10, input voltage is 10, capacitors, ground connection. That's it. Yes, sir. That's all about step-down voltage regulators.